All right, hi folks. I'm recording a video for Section 6.4, and Section 6.4 is related to working with graphs of sine and cosine functions. To get started here, let me just give you a quick reminder of what the graph of the sine function looks like. So if you recall from looking in the textbook, if I was to graph the sine function, on the horizontal axis, I'm going to plot the angle, call it x, and then the vertical axis here is going to be the function sine of x. And usually we mark this horizontal axis going from 0 to 2 pi radians. So let me mark this horizontal axis from 0 to 2 pi radians. And let me also add degrees underneath just so you can relate this to degrees. Remember, pi radians is the same as 180 degrees. 2 pi radians is the same as 360 degrees. All right, let me plot this in red. You might remember the sine wave has this cyclical pattern. I'll try to draw this the best I can. This is not the best sine wave in the world, but hopefully you get the idea. This peak happens at a height of 1, and the amplitude of this wave is defined as this vertical height from the midline to the peak. So this height is called the amplitude. Another measurement we're interested in is called the period. And the period is the horizontal distance you travel to see one full cycle of the graph. So imagine I start here at this purple dot, and I follow this path and return back to the same location. So I've just sketched out, and going from one purple dot to the other purple dot, I've just sketched out one full cycle of the sine wave. How far of a horizontal distance did I just travel? That's the period. Well, in our example, the period is 2 pi for this example. All right, but we want to look at the example they're giving us, which is y equals 3 sine pi x. And we want to know what is the amplitude and what is the period. Well, it turns out if you go to page 412 in the textbook, gives you a sine wave that looks like this. It says y equals a times sine omega x. And the textbook says when you have a sine wave in this format, the amplitude is the absolute value of a, and the period is 2 pi over omega. Omega really is the coefficient of x here. All right, so let's work out the amplitude first. Well, according to our equation, our a matches up to the number 3. So for our amplitude, I want to take the absolute value of 3, which of course is just 3. By the way, notice the amplitude is always a positive number. Okay, so amplitude is always going to be a positive value. How about the period? Well, in our example, our omega matches up to pi. Remember, it's like the coefficient of x. So our period is going to be 2 pi over pi, which is just 2. So let's see their answer. They said the amplitude is 3. We agree with that. But they said the period is pi over 2. We disagree with that. Right? Our period was 2, not pi over 2. So the answer to this question is false. Their statement is not correct. So we're going to say false on that one. Okay? All right, let's go to the next question. Let's do a few more of these examples. And by the way, if you go to page 412, you'll notice that it's the same format for either sine or cosine in terms of evaluating the amplitude and the period. All right, so let's do this example that involves cosine. So they're giving us here that y equals negative 3 cosine 6x. Well, I'm comparing this to y equals a cosine omega x. And it's going to be the same amplitude definition. and the same period definition. So all we have to do is plug into these formulas. For the amplitude, RA matches up to -3. But remember, the amplitude is the absolute value of A. So I've got to take the absolute value of -3, which is +3. For the period, our coefficient here of omega matches up to 6. So this is going to be 2 pi over 6, which I can simplify to just be pi over 3. So that's the responses for this one. The amplitude here is 3, and the period is pi over 3. And down on this menu, I can grab the pi symbol. So I'll write it as pi over 3. Okay, let's jump to another example. Let me clear the screen here. All right, what's the amplitude and period of this function? Well, for this one, the only thing I got to be careful about is when I compare this to the general formats here. So they're giving me y equals (9 cosine x). I'm really going to think of it as cosine 1x. Okay, well, A matches up to 9 in this example. That omega matches up to 1 in this example. So the amplitude is the absolute value of A. That's the absolute value of 9. Of course, that's just 9. And the period is 2 pi over omega. So the period is 2 pi over omega, but in this case, that's just 1. So 2 pi over 1, or just 2 pi. Okay, so the amplitude here is 9. And they ask us for the period. We came up with 2 pi. I'm going to grab pi from this menu on the bottom of the screen. And we have that one. Okay, maybe we can go to the next one. Let's do one more like this. So in this example, they're asking us to look at y equals -4 cosine 8x. The A here is -4. The coefficient omega is 8. So the amplitude is the absolute value of -4, but that's 4. And the period is 2 pi over that coefficient omega. So this is going to be 2 pi over 8, or pi over 4. Okay, so we know the amplitude and the period on this. In this example, the amplitude is 4, and the period is pi over 4. Okay, so page 412 is going to be a useful reference for some of these questions. Let's take a look at this one because this one's a little different. So on this one, they're asking us to, again, find the amplitude in the period. Well, this fraction 3/7 corresponds to our A value. So I know the amplitude is the absolute value of 3/7. That's just 3/7. But let me look at this cosine part here. Now I'm noticing it's cosine of a negative angle. Well, what I'm going to do before I apply, the theorem on page 412 is I'm going to remember that cosine of a negative angle is the same as cosine of the positive angle, right? You might remember as an example, if I had cosine of -30 degrees, it's really the exact same answer as cosine positive 30 degrees. So I'm going to apply that property and rewrite this as 3/7 cosine 2 pi over 7x. So now our coefficient omega is this 2 pi over 7. So now let's figure out the period. Remember, the period is 2 pi over that coefficient omega. But in our example, it's going to be 2 pi over 2 pi over 7. All right, now here's what I'm going to do to make this fraction a little easier to work with. I'm going to put 2 pi over 1 because I want to make this look like one fraction divided by a second fraction. But the way you divide fractions is you keep the top fraction as is, change to a multiplication, and flip or invert the second fraction upside down. So I'm going to make that 7 over 2 pi. When I do that, the 2 pi's cancel out top and bottom, so I'm left with just 7. So it looks like the amplitude is the fraction 3 over 7. And the period we figured out is just 7. All right, maybe we could do, let's do one more. All right, here, let me show you how to graph these functions using the graphing tool. So let me clear the screen here. And so they're asking us to graph 4 sine x and to show 2 full cycles. All right, so what I'm going to do is click on the graph and notice there's a sine tool here. Notice this icon is a sine wave, and if I hover my mouse over, notice it says sine tool. All right, so I'm going to click that. Now when I click that, it's going to allow me, and I'm going to click on the graph, and now notice it's going to allow me to type in the amplitude and the period. Well, the amplitude in our example is an amplitude of 4. And the period in our example is 2 pi. Because you can imagine that there's a 1 in front of this x, so our omega is 1. So our period is 2 pi over 1, which is just 2 pi. So I have graphed this function by plugging into this menu here. So I entered an amplitude of 4, period of 2 pi, and really my MATLAB has graphed it for me. Okay, and you can notice the height of this sine wave is 4, that's the amplitude, and notice the horizontal distance to see one full cycle is 2 pi, that's the period, and so this is the graph that my MATLAB is looking for. So use the sine wave tool. You manually enter the amplitude and the period, and the my MATLAB graphing tool does the rest. All right, hope this is helpful as you're getting started in the Section 6 homework.